Evet değerli izleyicilerimiz, Araya teşekkür ediyoruz. Şimdi sırada uzaklardan bir konuğumuz var. Private AI kurucu CEO'su sevgili Patricia Tein bizlerle. Hem biraz güvenlik ve işin güvenlik tarafını konuşacağız aslında. Deyip ben aslında Patricia'yı bırakmak istiyorum. Patricia, welcome.
Thank you very much. Very nice to be here.
Yeah, this stage is yours and you can start.
Thank you. Just going to share my slides. All right, well, very nice to be here, everyone. I'll be talking about how you can integrate privacy into large language models in a very practical way, and how you should be thinking about it from the very beginning. So first of all, why do you care in the first place? Of course, there are legal obligations. You would be, in Turkey, you're probably most familiar with the GDPR, given the proximity to Europe. There's also the CPRA in California, a number of other data protection regulations worldwide. The fines also are growing in terms of non-compliance for data protection regulations. And also there's a concern, of course, of cybersecurity. And if you collect massive amounts of personal information, what happens if you when you get breached? So in addition to that, the market also very much cares. This is the biggest drop in stock market history of Meta, in part because of the change in Apple's settings around privacy. And in addition to that, we see things happen by accident, and that's why you have to have preventions, like a ChatGPT bug temporarily exposes AI chat histories to other users. So what if you had sent personal information, like healthcare information, questions within the chatbot with identifiable data? That would be concerning. We also saw earlier this year, Italy's privacy watchdog banning ChatGPT over data breach concerns. Of course, it got reinstated after it put in other measures in place, but it's something to think about, again, from the very beginning. And this concern about privacy in large language models, or language models in general, isn't new. We saw Scatterlab, for example, in this report from 2021, the South Korean company that had boasted about the billions of conversations that they had between users. They trained their models on them, and then the models started spewing out entire names, nicknames, addresses in responses, which is, of course, very concerning when it's your information being sent over to other people in a chatbot. Research was already showing the likelihood of memorization of personal information, or rare information in particular. In this case, the paper by Carlini et al., they had put in a canary, so a set of random numbers that they put into the Pentree Bank database, trained a character language model on it. And what log perplexity is showing is the amount of surprise the model has in seeing that sequence of numbers. And the sequence of numbers that was put in the Pentree Tree Bank database the model was less surprised in seeing it than the other sets of random numbers. And just as an aside, I should add this slide into here. There's also a very big concern around the vector databases and how the vectors themselves can expose personal information that you can extract from the vectors. In a study from the University of Toronto, they showed that you could have word embeddings be closer, first names to last names and names to medical conditions if you were training on medical information, and then making those word embeddings public. That would be very concerning as well. Of course, there's continued research. This paper in 2020 by Carlini et al. Also showed that GPT-2 was spewing out, had memorized addresses and other personal information as well from the World Wide Web. And of course, it is public data because it is on the World Wide Web, but there's also the question of consent. So if you look at the GDPR, for example, you need specific consent for specific uses of personal information. And so it's very questionable when you have models trained on personal information without that consent. But what often gets missed is with the GDPR that says that if you anonymize data, it falls outside of the scope of the legislation. Is that anonymization isn't just about removing direct identifiers like entire names, social security numbers, credit card numbers. Anonymization is also about removing quasi-identifiers. And even if you're not anonymizing the data, quasi-identifiers are still personally identifiable information. You still need to minimize the amount of quasi-identifiers that you collect. And quasi-identifier examples are things like religion, approximate location. When you combine these together, that exponentially increases the risk of re-identification. In addition to that, I also want to point out that quasi-identifiers can lead to bias. So for example, you might include in a prompt somebody's location or somebody's religion, and that might result in a response that is biased. So with all of that motivation in place, I want you to start thinking about how it is that you're going to integrate privacy into the large language models that you are either building, fine-tuning, deploying, and it really starts with the prep work. First of all, you need to conduct a data protection impact assessment within your organization. So to identify, address any potential risks when deploying the solution. And what I'm going to go into next is what kind of information you should be including in that data protection impact assessment. In particular, when it comes to training, you do need to comply with the GDPR with having a legitimate basis for processing the personal data, either user consent or legitimate interest, and you could look up exactly what is covered by legitimate interest under the GDPR and whether your data falls under that, or your use case in particular. And you need to follow data minimization principles, which means you only collect the absolute necessary personal information for your task. Then at the validation stage, what you need to think about is the accuracy of the model, what kind of real-world data you're going to be processing, where you're going to be processing that data for validation. Also, you have to make sure that you have the appropriate data minimization standards in place for the data that you're using to validate the model. And you also need to make sure that any third party you're using is compliant with data protection regulations. So that should all go into the data protection or data privacy impact assessment. At deployment, you also need to be aware of where the personal information is traveling from and to. Oftentimes you can, for example, remove the personal information directly in your customer's environment in order to prevent that transfer of data into your systems, which is preferable. The less the data travels, the fewer locations it's at, the less vulnerable it is. And you also need to make sure that you're preventing any unauthorized access to the data. And that's one point that I want to drive in also on the training side. If you are training models on personal information or confidential information, you are going to be potentially exposing that information to people who don't have access to it. So whatever data that you train on has to, the models that you train on whatever data have to have the same level of access control as that original data that you trained on. That's not something that you can overlook. And then in operation, you have to worry about the inference. So you need to in particular worry about which third parties that data is being sent to, whether they comply to the GDPR, whether there's whether there's a way also for the users to seek explanation for what's happening with their data. So you, under the GDPR, also have to comply with access to information requests, and then also request to be forgotten. So that becomes really tricky because the law is still very murky about what happens to any personal data that needs to be removed from the models, or if there's a request to be forgotten and the data was trained on that person's information, does the model have to be retrained? There's ongoing research about whether or not you can selectively remove information from a model, but that is not presently possible. And in addition to that, you also have to think about perhaps you got consent for a particular use case for this large language model for training with their users' personal information. However, maybe you want to explore other use cases as well, in which case you have to go back and get consent for that as well. So what to do? You can do variations of de-identification. I'll go into a few of those. There's redaction, for example, and what redaction it means is you're getting rid of the what you really don't need, but you're not making a promise of anonymization. So this is necessary regardless, because this provides you with the ability to minimize the amount of personal information that you're using. Pseudonymization is a form of redaction. It can be anonymization. It falls under one of the types of de-identification. And it is a requirement of the GDPR. So basically, pseudonymization is replacing the personal information with placeholders, and then you can have a database in the back end that relinks the original data to the pseudonyms. Tokenization is a form of pseudonymization. It's just generally you have a reversible, it could be a reversible operation as well. And one thing I want to show you that is really cool that we've been working on at Private AI is the ability to de-identify the prompt all within your environment, send the de-identified prompt to your large language model of choice. Then the response contains the redacted information, and then there's a re-identification process that happens in your environment. And all of this happens very seamlessly, so you can still have a very pleasant user experience, and you could select what kind of personal information is particularly relevant to send through. So the cool thing about this is, as well, is that it works across 52 different languages. You can try it in Turkish. Let me know what you think. And the data never leaves your workflow. And another really cool thing is that you can integrate this directly within any large language model chatbots that you're creating for yourself. You don't only have to use the UI. And another piece of interesting form of de-identification is synthetic PII. And this can be useful, for example, for training large language models or fine-tuning them. So what you're doing is replacing names with fake names, times with fake times, locations with fake locations. And so you still have the flow of the language that's very seamless. And finally, I do want to get into anonymization. What I do want to mention is anonymization is it's not something that you can just do as a non-expert. You can follow certain guidelines. The guidelines aren't very comprehensive. And I wish the GDPR was, for example. That what I do recommend, if you do want to anonymize data to be outside of the scope of the GDPR, is do your best within your organization to anonymize the data, and then loop an expert in to do a re-identification risk assessment. So in a re-identification risk assessment, basically you're calculating with the personal information that is left within this data set, how likely is it that the different individuals that are within the database or within that are mentioned within this data set to be re-identified. And that could be things like you have a religion that's mentioned and you have a location that's mentioned. How many people in this location follow that religion, for example? There isn't too much research on unstructured data de-identification, not yet at least. What I do recommend, if you are interested, is to take a look at these two papers. and happy to send that reasoning about unstructured data de-identification to anybody who's interested. And one thing I do want to mention is what happens if you misuse terminology. So anonymization has been a word that's been misused, and you might have seen headlines that say anonymization doesn't work because such and such company anonymized data and it got re-identified. Here are some use cases where this terminology was misused. So here we found that patients can be re-identified without decryption through a process of linking the unencrypted parts of the record with known information about the individual, such as medical procedure and year of birth. So this would fall under HIPAA in the US, most likely, and this means that they weren't actually following the current guidelines for HIPAA de-identification. Year of birth, for example, should not be there. It should be a range. So it could be, if it's 1995, it should be between 1990 and 2000, for example, depending on the other information that's in there, how that leads to re-identification, and also for the actual use of the data. So if it's being used for research, that date range has to be accounted for. Here, a 2016 study found that a 42.8% risk of matching anesthesia records to the Texas inpatient public use data file for 2013 using data such as age, sex, hospital, and year. That is a lot of information to include without having a date range for year, an age range for age, a date range for year, and maybe you need a hospital, maybe you could have an approximate location of the hospital, depends on the use case. But this is, of course, a lot of very specific information that can be combined together. Sweeney was then able to uniquely identify the medical records of Governor Weld. She did this by noting that only 6 voters in Cambridge had the same birth date as the governor, only 3 of those were male, and only 1 of those lived in the same zip code as him. This was one of the this was the first study that was showcasing the current methods for removing personal information are not good enough. And this was, of course, showcasing, zip codes are very specific. And what this led to was, instead of you being able to leave a zip code in, what you can do is have leave state level information, or you need to see how many people are within the geographic area of the portion of the zip code that you maintain. And this is another really interesting paper called A Systematic Review of Re-Identification Attacks on Health Data. And this is by Khaled El-Imam, the professor from the University of Ottawa. And here it's questioning, does anonymization work? And it goes through all of the re-identification attacks since or up until the point that this paper was written, and questions: did they follow HIPAA safe harbor? Were the re-identifications verified? And if you look through all of these, there's only one that did follow HIPAA safe harbor. That's the one below, that actually had verified de-identifications, and then 2 out of 15,000 people were re-identified, and that falls below the re-identification risk threshold of HIPAA, so of 0.04%. And so what you need to keep in mind is nothing is perfect. Anonymization isn't going to be perfect. You need that risk threshold to calculate. Cybersecurity infrastructure that you put in place isn't going to be perfect. What we're doing is putting in place as many barriers as possible for people not to misuse data, or not for that data to not become vulnerable to attack. And this should be one tool in your toolkit. In addition to anonymization, you should still have proper access control in place. You should still have proper cybersecurity in place. Same with data minimization. Same with any other privacy-enhancing technology that you use. You should always have it as a tool in the data protection toolkit. And what I really want you to take home from this is, given all of the steps that you need to do in order to make sure that a large language model is properly following GDPR and properly protecting user data, is to think about this at the point of design. And so if you are about to launch a large language model, or in the process of creating a large language model application, start thinking about how you integrate privacy by design, which is a written requirement of the GDPR anyway. And if you want to give the private GPT that I mentioned before of the de-identification within your environment, please go ahead and try it out from this QR code. Thanks so much for your time, and happy to take any questions.
Thank you, Patricia. It was a very good presentation. There is only one question from our audience for you. Mr. Ozan Akbaş asks, can you further explain synthetic PLL? Yes.
Sure, synthetic PII. So, so further explanation. So this is basically using the context in order to generate the information that can be replacing the names, replacing the origins, and so on. What is there anything in particular that the person asking the question was curious about?
Yes, I think. Okay. Thank you, Patricia. See you next time in Istanbul, maybe face to face. Bye.
Hopefully. Take care. Thank you.
All right.